This module will present 3 case studies of leaky homes to give you a sense of some of the characteristics and variabilities that can exist in the amount of air leakage in homes depending on their size, construction, and conditions. We'll take a look at 3 houses of very different ages, construction types, and their measured air leakage characteristics. Each of these homes is located on the campus of the Kiski School in Salzburg, Pennsylvania, where they serve as faculty housing, and each of them was inspected by the same professional auditors affiliated with the National Energy Leadership Corps in November of 2011. The first school is a contemporary house. We'll call it house number 1. It's a 2-story, 4-bedroom house, about 2,800 square feet, and it was constructed in 1965. It has a brick veneer, an overhang on the rear facade, and a concrete block foundation with wood framing, and the single pane windows are double hung. It's heated by a natural gas furnace and supplemented by a wood fireplace. And in this particular house, the blower door test identified an air change rate at 50 pascals of 12.37, which is pretty high. Taking a look at the sources of heat loss when the house was inspected, there were some real obvious reasons for that high measured air change rate, including some windows that were permanently open, propped open to allow extension cords coming in and out, as well as other numerous problems with penetration through the foundations. Some infrared camera studies identified uninsulated and unsealed rim and band joists. And those can be shown here in the images by the darker black images that are showing from the inside as cold surfaces, and an indication of spaces where heat is being lost in this particular house. The next house, called Reese Hall, was much bigger, almost 7,000 square feet and 2 1/2 stories. This one was built in 1912, had an old rubble stone foundation, wood framed using older balloon style framing methods, and much larger and much more complex than house number 2. You can see that there are a number of protrusions and visible air conditioners, and as you would expect, a fairly leaky house, and considerably older than the first. However, when it was measured, it was found to have almost the same air change rate as house number 1. House number 3 was referred to as the Cottage. This was the oldest of the 3 homes, constructed somewhere between 1860 and 1870. It had visibly settled over the years, but it did have new modern vinyl siding and vinyl windows. But it turns out that these were cosmetic fixes that made the house look updated, but actually it was one of the leakiest homes the auditors had ever seen. It had an air change rate of 27.1, and using infrared cameras was determined that there was absolutely no insulation anywhere in the house. Taking a little bit more of a closer look at why this house was so leaky, there was a original heating source of a wood fireplace, but that had been removed, and a chase that was left behind that allowed air to pass through it. The natural gas furnace was installed long ago in the 1860s, and it hadn't been upgraded. The ducts of the house and system were found to be very leaky, and most of the summer cooling was provided by window-mounted air conditioning units, which had also been allowed to grow fairly old. But upon inspection, the building furnace baseboard looks fairly harmless. The modern vinyl windows look like they're part of a well-constructed home, but the real culprit was found in the basement. An uninsulated and unsealed floor and an unconditioned space beneath the floor allowed a significant amount of air convection and infiltration and substantial heat loss, and it was that infiltration through the floor that was causing the dominant amount of air leakage in this particular house. So to summarize, the first house, modest size and fairly recently constructed, an air change rate of 12.37. An older home, much bigger, had a similar air change rate, but overall a lot bigger volume of air to heat and cool, so probably using significantly more energy than the first house. And the third house, the smallest one, with an air change rate of 27.1, which is almost off the charts. And it goes to show that while the last house might look newer and with fairly updated construction, it was actually the least efficient of all these in terms of air leakage. And this is why a blower door test is a valuable tool to assess the actual conditions and infiltration rates of a particular home, because you can't always judge how leaky a house is going to be just by how it looks.